Hello Internet, I'm Remote Leg, and welcome to the LifeStyles project, a study of ALife. Welcome back to my artificial world. Let me take away all the liquids and solids. See this little green dot? That's ALife, that is. Yes, it works. This little green dot is a living, breathing ALife creature, crouching quietly, staring at our artificial landscape. The brightness of the dot indicates the health of our creature. If you look closely, you can see that the dot is gradually growing dimmer, and dimmer, and dimmer, and now it's dead. Right, thanks for watching. This has been a Remote Leg production. No, I wouldn't do that to you. We've come too far. But I would like to highlight what's changed since the last video. We've added a lot of new buttons, like a life button, a species button, species 0 button, the seed life button, a radio button to display life on the map, and also some settings to display map lives showing either their age or their health. There's a lot of extra baggage that's required when we add life to the world. You might also be wondering why the screens look very different. Well, my old computer died 2 weeks ago, so in addition to creating ALife, I've also had to buy all the parts and build a new computer to replace my old one. I also upgraded to Windows 10, and that's why all my screens look different. It's been a busy week. I've reset the world back to square one. Let's see what went wrong with the first life I created. Here's the life screen with its statistics. Life 0, our first life, and species 0, our first species. Having species allows us to offload lots of information to the species array, so we don't need to duplicate it for all the lives of the same species. Also, having species allows us to explore the family tree to see what mutations have occurred and how we got here. This life is at location 300, and that's the middle of the map. Remember, our world is 600 by 600. Age 0, it's just been born. They're born with a little bit of energy, so they don't die straight away. I made the rule that lives need energy to survive, and when the energy reaches 0, they die. I was tracking energy and health separately, but decided to roll everything into energy to simplify things. The stomachs are all empty because it hasn't eaten anything yet. I decided to give each life a separate stomach for each substance it can eat. This allows a life to mutate, so it specializes and eats more of one substance than another. Lives can't eat bedrock because you might recall I want bedrock to be immovable, but I left it in because it was simpler. In each cycle, a life will check what substances it can eat and digest. I added last substance checked, so I can vary which substance is checked first at the start of each cycle, more randomness. Spawn cycle will increase by 1 each cycle until the life is ready to spawn children. Then it will reset to 0. Here's the first species, species 0. These values apply to all lives of this species. Who the parent species is. Obviously, species 0 has no parent. All lives of this species will die when they reach 40 cycles of age. This species can't store more than 30 units of energy. Once the energy tank is full, a creature will stop digesting food on the current cycle and keep the remaining food for later. This is how much of each substance this species can hold in its stomach at any time, its capacity. Once it's full, it can't eat any more. This forces the lives to balance how much food they have in their stomachs with how much energy they have. Too much food and not much energy means the life might die before it can digest the food. Too much energy and not much food means the life spends all its time on the verge of starvation. The capacity for bedrock is always empty. 0 means this species cannot eat any bedrock. In order for a life to digest food, it must reduce the temperature of the food in its stomach below the freezing temperature for that substance. If you recall the physics model I've devised, this causes the substance to morph into the next lowest substance, releasing heat. The life can then use this heat to refill its energy tank. Neat, eh? So this number means that species 0 has a stomach temperature of 2.007 degrees that it can apply to its food. These next three fields are all to do with spawning children. This species will try to spawn children once every 7 cycles. On a spawn cycle, this species will try to spawn 2 children. On a successful spawn, the parent will give each child 10 units of energy from its own energy tank. Once again, the parent must balance its spawn parameters. Each time a child is born, the parent gives it some energy, but giving too much could kill the parent. Therefore, the parent must have a break between spawns so it can replenish its energy supply. If a life of this species successfully spawns its maximum allotment of 2 children, it had better make sure it has more than 20 units of energy, otherwise it'll die in childbirth. The last field is the energy required to exist. Every cycle, this amount of energy will be deducted from the life's total, and once again, if the total falls to 0, the creature dies. This last field is calculated and is dependent on the species values above. Things that make life more powerful, bigger stomachs, longer lifespan, etc., cause this figure to increase. This is to add balance, otherwise evolution would just turn into an arms race to max out all the statistics. Now evolution must choose whether it's really better to live 10 years longer, because that improvement will increase the daily energy requirement. Conversely, reducing the size of its ether stomach might be beneficial if there isn't much ether about, because that species will require less energy to survive. I know a cycle is not the same as a day, but I call it this because daily energy required sounds better than cyclic energy required. Enough of that. Let's look at our first life to find out why it died. I'll set the system to only run for 1 cycle, so we can examine our life after each one. And away we go. 1 cycle done. Let's check our life. As expected, the energy level has gone down because of the daily requirement. We see that this life filled its salt and dirt stomachs to their maximum allowance, but no other food was eaten. Let's look at location 300-300. Yep, it only ate salt and dirt because that's all there is to eat here. What a desolate world we've created. To be fair, if it was further south, the landscape would be affected by the sun and there would be more choice. Now we cycle once more. The energy has decreased by the daily requirement, but no food was digested to increase it back up again. Why? The digestion temperature is 2.07. Let's look at the substance table. The freezing points for both salt and dirt are colder than 2.007. So this life can't get its stomach temperature cold enough to break down these substances. So that's the cause. This life is eating food it can't digest, and that's the only food about. We're having this problem because species 0 is not viable for this location. This would never happen in evolution because this species would die out very quickly and not spawn any children. We're having this problem because this life has been artificially generated in a lab. So, how to fix this? I could increase the freezing point of these foods so our species can eat them, but that would also tweak the world physics and will impact the balance. Remember the problems I've had with that in the past? No. I think it's better to re-engineer the species rather than mess with reality again. Let me drop its digestion temperature low enough to digest salt but not dirt. Here's the form that allows me to configure species 0. Now just lie back, this won't hurt a bit. I'll just make a little incision here, pop this value in here, and we're done. All I need to do is go into the life file and ruthlessly slaughter our little creature so that I can reseed the world with a new one. And here we are. Okay, I've removed the countdown timer, so we're going to run for, well, as long as it takes. As you can see, there's the life in the middle of the thing, so we're looking for spawning. We're looking for some children. Oh, now is that another dot? It's hard to tell. Yes. I think it's still alive, at least. That's something. Now, let me zoom in. on that location and see what we've got. And there they are. Oh my goodness. Life. Oh, and they spawned, and look at that. Life. Now we have stopped. Why have we stopped? Oh, the maximum number of life IDs has been... I set a hard limit on the life IDs to be 10. There's no reason for there to be a limit because the life ID is just a number. So it can go as high as the machine can handle. But I set it to 10 just to make sure to test the fact that it was reaching the maximum. So that's fine. But look at this, we've got 17 lives have been created. When it reaches 10, it just keeps adding numbers, but then it sets itself to shut down as soon as possible. So that's why we got 7 more than the maximum. But there it is, there's life. Now, the energy is looking good. Some of them, okay, they're very young. They're very young. Well, that's fair enough. The ones to the west and to the south have just been born, so they're a much brighter green because they're younger than the others. And the energy on the young ones is all 10, as we can see, so that's reasonable as well. And the parents in between have less energy because they gave birth, and the top, they're good. All right, this is looking very good. This is looking very good indeed. Now, I'm not sure what to check next because let's look at the species. Well, they're all species 0 because I haven't implemented mutations yet. But when I do add mutations, hopefully the species will change. They're all the same color because I made it so that all species of the same type, all lives of the same species, will be shown in the same color. Now, have these lives made any difference to the environment? Well, there's a bit of water here. Kind of hard to tell, really. Nothing appears on the visible surface map. Energy, no real change, no gases, the liquids. I can't see anything that looks different. Of course, the differences may be so subtle that they're just not showing up very well on these displays. No. Because if a life digests some food to create energy, and there's more energy created than it can use, it actually excretes that energy as heat. So wherever there's a lot of life, there's a good chance there's going to be some heat blooms appearing because they'll all be generating that little bit of extra heat each time they digest food. And of course, once the energy becomes full, they stop digesting food and they save it for next time, as I said before. So the heat here, like 54, that's a little bit higher than the locations around it. 29, 20. It's too small a change to be certain that this heat of 54 is not being caused by something else. So inconclusive at this stage. But I think the next step, I'm going to run this for a lot longer. And then we'll see if there's a difference made. So let me do that. I will increase the number of lives that can be created, and we'll run it again for a longer period of time. And here we are. I've reset the world. I've reset the lives and species, and now we're ready to run for a couple of 100 cycles to see what grows. We're off. This is taking too long. I'm going to speed up the video so you don't have to sit through it all. Look at that growth. It reminds me of lichen or perhaps coral. It's almost like it's pulsing on the outer edges. Looks organic, don't you think? I think it looks very pretty. My goodness. And stop. 2,631 lives. That's what it looks like. It's a very healthy colony. The lives are crammed in pretty tight. There's not much space between them. Maybe look at some world details. The pressure. Oh, there's a low pressure system above the colony. That means gases are being removed from the system. So they're breathing either ether or air, I guess. Let's have a look. Yes, the ether is gone. Oh, and it's much more visible on the air. Yeah, that's gone. Well, there's not enough foam or water to really tell. No, there is. You can see the water's missing. Salt, yes. Definitely eating some salt. Dirt, not as visible. Clay, no. And the bedrock hasn't changed, which is as it should be. Maybe look at some energy now. Oh, there's some heat blooms above the colony. Interesting. It's quite intense, some of that heat too. Let's zoom in maybe for a closer look. Yes, there is a lot of heat there. But that means they're healthy. Because if a life can't consume all the energy that's released by digesting the food, it radiates that energy as heat. So this heat actually means that the colony is very healthy. Well, there you have it. That's pretty good. It's a good start. The next step is, I think, will be to add mutations. See what direction natural selection takes us. That's going to be good. Okay.